Okay, and welcome back. In this section, we're going to go on and talk about placing the air monitors actually out in the field and the different steps that you need to follow in order to accomplish that. We'll also go on to talk a little bit about the analysis section in this portion of the presentation. So it's important to remember when placing the monitors out in the field that they need to be in a semi-enclosed structure. This is important because airflow is a big deal in collecting the nicotine onto the badge itself. So if you have a structure that just basically has a roof on it and no sides, it may be a little bit more difficult to accurately measure the amount of nicotine that's in that space. So we typically recommend a venue or a type of room or building that has at least 3 walls to it. And they can be somewhat open walls, have some windows in them that are always open or large cutouts. But it's important that there's some structural soundness to each of the rooms. In this particular study, we left, again, the monitors in the hospitals and restaurants and bars for 7 days, but in schools and government buildings, we left them there only for 5 days because no one was actually there on the weekends. You want to go to the building at a time of low occupancy, meaning you don't want to be there at lunchtime at a restaurant when there's 100 people in line to get food and to try to place the monitor up on the ceiling because you'll get a lot of questions and a lot of looks and stares. And if that's the case, regardless, if there's a couple people there, you could still get some questions. And you just want to be honest about what it is that you're doing, but not so specific and detailed that you might alter the behavior of people who are visiting that particular venue. So for instance, if you're at a restaurant and somebody comes up to you and asks you what it is exactly that you are doing, you can just tell them, well, you're here to do an air monitoring study, which is the truth. You are there to monitor the air, but you don't need to really go into any detail about how you're looking to measure the levels of secondhand smoke in the air in an effort to maybe change the policies of this restaurant to make them go smoke-free, because people might take that the wrong way and might change their behavior and not smoke near anything that looks like an air monitor, which would give a false reading of what's actually going on in that particular building. Again, you want to stress or make sure that when you're out there in the field that you're placing the monitor in a location that's representative of the entire area that you're wishing to monitor. So if you're looking to monitor a restaurant, again, or a bar, let's say, you don't want to put the monitor in a far off dark corner where nobody typically is sitting, or you can tell that there aren't any tables over there. Or if you're at a school, you wouldn't really want to place the monitor in, like, for instance, a janitor's area, since not a lot of people pass through there, only typically the janitors. But again, that's also based upon what your goals and objectives are of the study. If you want to get an overall sense of what's going on in the building, it's important to place the monitors where people are visiting frequently. So when you're out in the field actually hanging the monitors, you want to make sure that you hang the monitor approximately 1 to 2 meters at least off of the floor in an effort to make sure that people don't spot them easily and start playing with them or take them down or contaminate them any further. It's also ideal to keep it off the floor so that it's more in the immediate breathing area of somebody who's in that room or venue. But at the same time, the monitors can be placed high up on the ceiling. That's an ideal location so that, again, no one can quickly tamper with them and they're not easily spotted. Again, if someone sees it, they're not going to change their behavior because it's so high up. Generally, people aren't staring at the ceiling. But at the same time, you need to remember to keep the monitors away from windows or ventilation systems if possible. The airflow, as we mentioned before, with putting the monitors in open air spaces, if there's too much airflow, it may dilute the amount of nicotine that's captured. Again, if the space is wide open or if there's a lot of air flowing through, it could potentially dilute the amount of nicotine that's actually captured on the filter badge itself. So you just want to try to avoid these things. It's understandable that that's not always the case in certain environments, especially in warmer climates that have a lot of windows, have a lot of fans. So you just really need to use your best judgment. But as a rule of thumb, we generally say at least 1 meter away from these types of locations. And on your sheet that you collect data on, your observation sheet, you can go ahead and mark these types of things on there so that back in the lab or during data analysis, they could take a look, oh, well, they said they saw 500 smokers on average in this particular bar, but the readings were really low. So they could go back to the sheet and notice, well, there were a lot of windows, it only had 3 walls, there were a lot of fans going on at the same time, so that could all play a factor in it. We also like to say that you'd want to keep the monitor at least 1 meter away from a potential regular smoker. This is a little harder to actually discern when you're out in the field, especially if you're going there at low occupancy. But if you're going into, perhaps like a regular bar that has a lot of regular smokers and, they have like a permanent sort of ashtray fixture there, and that's generally where a lot of smokers congregate and the non-smokers hang out at another part of the bar, again, you wouldn't really want to just keep your monitor at that particular location because it's biasing your results that you'd be looking at later during analysis. So some good places to put the monitors could be beams, nails, or even plants or lamps. Curtains are not ideal. They can actually sort of suffocate the monitor or block the airflow. Just need to look around, make sure that the monitor is going to be in a safe place where people aren't going to tamper with it and that there's good airflow. So again, don't hang the monitors in areas where air does not circulate, which we refer to as dead spots. These would be curtains, as I just mentioned, but also corners or under shelves or under tables. That's not always an ideal place to put them. And again, really want to stress that you don't want to put the monitor in a place that's really visible or accessible to other people. So we don't want the monitors to go missing or to rip the windscreen or to alter people's behaviors. As I mentioned earlier, when installing the monitors or even just handling the monitors, you want to make sure your hands are washed, especially if you use any type of tobacco. If you smoke cigarettes or you use oral tobacco or use a water pipe, any of that can be transferred to the monitor. Some products actually contain nicotine in them. There's lotions that actually contain nicotine. So even if you don't think you use any tobacco products or nicotine products, it's still advisable that you wash your hands thoroughly before taking the monitors out into the field or even receiving them or shipping them to the lab. So you want to open the container with the air monitor in it, open up the little plastic cup, pull out the baggie, open the baggie, take the monitor out, and verify that 4-digit number that's written on it that the lab put on there, the sampler code, and verify that that code corresponds with the building code and the label and the sticker that's actually on your sample sheets that you've completed. And if you need to actually write in that 4-digit code, this is the time that you would do it. So your label may only have the country, the city, the building type, the building number, and the field worker, such as yourself, may be responsible for completing in that last 4-digit number. This would be the time that you would do it. So then you'd be ready to go ahead and actually remove the cap off the monitor, exposing that windscreen to the ambient air and the environment that you're wishing to hang the monitor. So you want to be careful and always handle the monitor laterally so that it's not in a position that could get it damaged or you could accidentally rip the windscreen. So you want to verify that all of the pieces are there, that the windscreen is not ripped, and that the filter is actually there and that it's all screwed together and it's nice and tight and ready to go and that the clip is there. So you want to make sure then that your windscreen is actually facing the room being monitored. And again, just emphasizing that either side's not being smothered or blocked so that airflow is going through both sides. You can use the clip to place the monitor, but you always want to make sure that it's very secure. So if you need to use the tape or use some string to affix it or to adhere it to a surface, that's perfectly fine, as long as that's also secure and again, not sort of suffocating or blocking the airflow of the monitor. And then you want to just make sure that you indicate the time that you place the monitor on the sample sheets or any of your other data collection forms, because the time that you're actually placing the monitor, visiting, and removing the monitor is essential for the lab to conduct the analysis so that they can verify and understand the amount of exposure that that filter pad had to the ambient air to collect nicotine. So we're moving on to something referred to as blank and duplicate monitors. As we discussed early with the table that had the list of the types of buildings, the places within each of the buildings, and the number of monitors that will be placed in those venues, I mentioned that there's something called quality control monitors, and that actually refers to blank and duplicate monitors. The purpose of these monitors, you have a blank and a duplicate, and they're a little bit different. So the blank monitor helps control for exposure to tobacco smoke that may be occurring in the field naturally or already there. So you want to sort of get an idea of what this background exposure is. They tell us if there's any sort of contamination on the equipment that might need to be investigated once the monitors come back to the lab for analysis. For instance, perhaps when the monitors were being assembled, the lab personnel didn't wash their hands or were not wearing gloves and they contaminated the monitors. Or in the field prior to being placed, the field workers weren't washing their hands and they were touching all of the monitors and all of the monitors were exposed. And since these monitors are not actually put out in the field, that would sort of give us an idea of what was going on, again, like I said, in the background. Not necessarily what was actually happening in each of the particular environments, but it's something that we'd use as what we refer to as a correction factor. So the blank monitors account for approximately 10% of all of the monitors that you use in the field. So if you have 100 monitors that you're going to be placing, what we might refer to as regular monitors, 10 of those monitors will have to be blank monitors. So you'd have 10 additional monitors that would go out in the field. So if you remember that complex table, which we'll look at in a few seconds here, you had in parentheses the number of monitors that would be quality control monitors, which is 10% of each of those samples. We'll review this a little bit in more detail in a few slides. But it's important to remember that the blank monitors cannot be used multiple times. Even though I said you're not going to be putting them out in the field and hanging them in a venue or in a particular room within a building, you can't use them again and again and again. If a blank monitor is assigned to one particular monitor, that is the only time that that monitor can be used. So the same with duplicate monitors. They serve a little bit different purpose, but you can't use them multiple times as well. They ensure that the experiment was run correctly, or that each of the other monitors is giving a reliable and replicable measurement. So the duplicates are, as they sound, sort of a twin monitor. They go or correspond to a regular monitor. So you place a regular monitor out in the field, and then you're also going to place this duplicate monitor right next to it to ensure that that regular monitor is giving an accurate reading. So this duplicate should provide almost the exact same measurement as the regular monitor. The duplicate monitors also account for approximately 10% of the monitors, or 10% of the regular monitors. And as I said, they cannot be used multiple times. So here's the table again that I was just mentioning and that we looked at earlier in the presentation. That documents or illustrates the number of different types of buildings that we went to. Within each of those buildings, the locations you're supposed to place the monitors, and the number of samples. So it's this column that I'm going to focus on for a few seconds here. So as I said, you have what I'm referring to as regular monitors, the monitors that are actually going out into each of the venues and being placed. And then in parentheses there, you see the number 6, for instance, for the hospitals. And that number 6 serves as a quality control. Those are 6 quality control monitors. In this instance, 3 of them will be duplicates and 3 of them will be blank monitors. And so I said for every 10 samples or a 10% sample, you would place a duplicate and a monitor out in the field. Well, you'd use a blank monitor out in the field. Let's go on and see exactly how this works. So assigning the blanks and the duplicates, as I just mentioned, it's a 10% sample. Or in other words, every 10 monitors, you would assign a blank and a duplicate to it. So let's take the example first of hospitals. So here you see H1 through H5, because we have 5 hospitals. That's what H1 stands for, H2 stands for hospital number 2, H3 stands for hospital number 3, etc. It's not the labeling scheme, it's just to illustrate that we have 5 hospitals. So you have 6 monitors per hospital. So hospital 1 gets the first 6 monitors. Hospital 2 would get the next 6, or 7 through 12 monitors. And I said for every 10 monitors, you place a duplicate and a blank monitor. So at hospital number 2, on the 10th monitor, you see I have a double asterisk there. That meant that that monitor would get a blank and a duplicate monitor with it. So if I were to pull up that sample sheet for monitor number 10, I would see that on that sample sheet it said that there was a duplicate monitor and a blank monitor corresponding with it. Those check boxes would be checked yes. Was there a blank monitor? Yes. Was there a duplicate monitor? Yes. So moving on then to hospital number 4, on the 20th monitor placed in the field, you see it also has a double asterisk, as well as the 30th monitor, meaning that at monitor 10, 20, and 30, you get a blank and duplicate monitor assigned. The same for schools. We had 5 schools, so school number 2, 4, and 5 at monitor 10, 20, and 30, we had a blank and a duplicate monitor assigned. It's really important again to stress that the blank monitors and the duplicate monitors cannot be used more than once. They are actually collecting information or actually collecting nicotine on them or any sort of ambient things that might be out there. You can't use them again. So just because the name blank sounds like there's nothing on it, you could take it back to the field and reassign it to another location. That's not the case. If it's assigned to a 10th monitor, a 20th or 30th monitor or whatever, that means it was used. Don't ever use those monitors again. So now let's discuss actually how you install the duplicate monitor. Earlier I mentioned it's sort of a twin monitor. It goes right next to your regular monitor. So you install your normal monitor, let's say on a beam, right in the middle of the room, a meter away from the door, a meter away from the window, and a meter away from any sort of fans or air circulation devices. You want to take your duplicate monitor, take off the cap, verify the number. If you need to write it on the form as requested, go ahead and write that sampler code number on your collection form, and then place it right next to your regular monitor. So you record all of the same information on that duplicate as you would on your normal monitor. Installing blank monitors, or the use of blank monitors, is a little bit different because they don't remain in the field with the regular monitor. So after you placed your normal monitor and you put the duplicate monitor right next to it, you would go ahead and take your blank monitor out of the cup, out of the bag, and you take off the cap, and you would expose it to that room environment where you have the normal and the duplicate monitor already hanging in place for 2 to 4 seconds. As I mentioned, this is just to give sort of a background idea of what's happening. It's not actually used to collect nicotine. You don't want a smoker to walk by and breathe into it, and you want to make sure your hands are still clean so that you're not contaminating the filter. After 2 to 4 seconds, you put the cap back on, put the monitor back in the baggie, and put the baggie back in the cup, and you take it back with you to where you stored the monitors originally, or to an environment that's completely smoke-free. Do not leave the blank monitor in the room with the normal or duplicate monitors, and do not use the blank monitor again. You just used it to record the background information, and you put those notes on your observation sheet, and so you've used the blank monitor once. So the blank monitors will be sent with the others to be analyzed. Just as your normal and your duplicate monitors will be analyzed for nicotine content, your blank monitors will be as well. The nicotine levels from the normal and the duplicate monitors, they'll be corrected for levels found on the blank. So as I mentioned earlier in the presentation with a figure and in other slides, room volume can play a factor in determining the amount of nicotine or the dilution of nicotine that's collected on the filter. It gives a sense of where it is exactly the monitor is being placed and what's actually going on in that environment. So it's helpful to measure the room dimensions, so measuring width, length, and height. So sometimes this can be achieved with using a tape measure, especially if you're going at a time of low occupancy. You can quickly whip out your tape measure and measure the length, the width, and the height of the room. But in other instances, you may not have a long enough tape measure, or you just may not have a tape measure at all. So what you can do is you can know how tall you are from the tips of your fingers to the floor and use that as a gauge to measure the height of a room. And you can also measure your stride, or how far your feet are when you take normal steps. So you'd have all of these things measured or have an idea of them before you go out in the field. So if you knew your stride, you could walk out the length of the room and the width of the room and multiply or add up your steps to determine the length and the volume. So for instance, if your stride was 1/2 meter and you walked out the length of the room, that took 20 strides, then you would just take 20 times 0.5, which comes to 10 meters, which would then give you the length of the room. You would do the same with the width. Then with the height, you can go ahead and just stand up next to the wall, know how tall you are from the tips of your fingers to the floor, and you can gauge or give an estimate about how much space remains from your tips of your fingers to the ceiling, and then add those two numbers together to give you an idea of how high the ceiling is. And then you would have the height, the length, and the width. This is all just an estimate. We don't need exact numbers to calculate for the volume, but it gives an overall picture, again, of the venue or the space that the air monitor is being placed in. I also mentioned that you can make some diagrams or pictures of where the monitor is being placed in the room. On our sample sheets, we've created a small little box on the back of the sheet where you would put a little symbol that designates that you put the air monitor there. And so here we actually say that we're only interested in doors that open to outside areas, meaning that if you open the door or the window, you'd be out of the building. You would see, grass perhaps or sidewalks. Some buildings, especially office buildings, have doors that open into hallways or open into other offices. We're not so interested in that. But if you wanted to document all of that, you could do so as well. But we're more interested in the windows and doors that open to the outside because that's where the airflow is generally coming in at and can potentially give us an idea of the dilution or how much air is passing through the air monitor. So here you see we put an X for one monitor, X1, and then an X2 for another monitor. So we've moved through day 1, we've placed our monitors, we administered our building questionnaire. Then you would want to go back again and make sure that you're visiting the monitor or just checking up on it to make sure that it's there. If the monitor goes missing or is damaged, you would go ahead and write that down on your sample sheet. And then on day 7, you would just go back and retrieve the air monitor and complete any other observations that need to be completed on your worksheet. So you've completed your study, you collect your monitors, you put them back in the baggies, back in the cups, and you take them back to the office, potentially for your project coordinator to prepare for shipment to a lab for analysis. In the meantime, before they actually get sent to the lab, you want to again make sure you store your monitors in a smoke-free environment at room temperature. We don't want any further contamination or any further exposure to the nicotine that might exist in any sort of environment. You want to copy any of your data collection forms for backup, and then you'd prepare your samples, put them back in the box, any copies of the sample sheets, and send them to the lab for analysis. If you're going to be doing data entry, access databases are very simple and user-friendly and can quickly contain all of your data, and then can also be sent to anyone who's doing your analysis for you. On this website, we also provide information on how to accurately enter data into an Access database. They can easily be created and shared and sent all over. It's a good way to store and organize your data. So once you've sent the data to the lab and you've entered your data into a database and you received the results back from the lab, you're now ready to do some analysis on it. You want to make sure that your data is clean in order to make any sort of inferences about the research questions and goals that are most relevant to your study. So you can do some basic descriptive analysis or a little bit more complex, such as a multivariate analysis. It can be helpful to have a statistician or someone that is technically trained in statistics to help give you a little bit more detail about your results, a little bit more information. But you shouldn't just stop at analysis once you see what was out in the field. It's helpful to disseminate those results to people such as policymakers or other organizations that can help have an effect or help change policy or change regulations on smoking, bans or smoking regulations that might exist in your city. It's important to do this transfer of knowledge in an effort to convey the information to the audiences or to the people that are most affected so that you have an impact with your research. So it's not just done to answer your own personal questions, but that the data can go on and serve a bigger picture, a bigger reason. So you need to then create a dissemination strategy, which is helpful to do before you actually start conducting the study. So you would have those two things being conducted or being organized at the same time. So then once you were done with analysis, you knew how to use those data points effectively. So the study objectives will actually influence who your audience will be in terms of your data dissemination strategy. Here we have an example fact sheet that was quickly put together, relatively easy to do, just sort of highlighting what it was that the research study did, what the findings were, and if there was any comparisons, so that they could quickly see that, even some of our non-smoking environments, we still see some smoking going on. What's the deal with that? We need to look into that. Apparently our smoking bans or smoking regulations are not effective or not being enforced appropriately. So that wraps up this presentation on air nicotine monitoring. If you had any further questions or needed any assistance, please feel free to contact myself or anyone at the Institute for Global Tobacco Control. You can email me at lhep@jhsph.edu or visit our website for further information.